Hey guys, it's Miss Miklos, and in this lecture we are talking about 9.2, which deals with ellipses. And we've talked about ellipses in Algebra 2, but today obviously we're going a little bit deeper, kind of like we did with parabolas. And I want to start with the definition of an ellipse. So an ellipse is the set of all points in a plane, the sum of whose distances from two distinct points, which are right here. The foci is the plural of focus, is a constant. So basically, every single point on this ellipse, if I add up the distances from the foci, it's going to be a constant value the whole time. And we really learned that last year. Now, what's a little bit different this year is we're going to talk about something called the major axis and the minor axis. The major axis is going to be on the axis that is bigger. Okay, so major is bigger. So if we see that we need to move out more in the x direction, then the x would be the major axis. The minor axis is the smaller axis. So that should actually make some sense to us. Before we get into all this stuff about the standard equation of an ellipse, I actually want to talk about some characteristics of an ellipse. So the three characteristics, both x and y are squared. There we go. It is x squared plus y squared. And so far that looks a lot like a circle. What makes an ellipse different than a circle is an ellipse, x squared and y squared have different coefficients. Okay, so in a circle, it would be like 2x squared plus 2y squared. In an ellipse, we might see things like 2x squared plus 3y squared. Okay, so that's what differentiates it. So now going into our standard form of an ellipse. Okay, we have two different equations here. If we look, the equations are actually really similar. Okay, important things that we need to know. The center is HK. We should be getting really familiar with that. Okay, and once again, we're taking that from the opposite of these values inside the parentheses. Something kind of new, our minor axes are links 2A and 2B, okay? And if we look at that, that is just taking twice the square root of whatever these denominators are. And last year in Algebra 2, we learned, okay, we're going to square root it, and it's going to tell us how far we're going to go to the right and the left, or how far we're going up and down. Now, this year, all we're doing is we're doubling the square root, so we're combining the distance we're moving right and left. Now, I actually prefer not to think of this as two different formulas. I think that's a little bit confusing. I would rather just focus on the fact that if we know this equation, we just need to know the bigger denominator is the major axis. Okay, so if we know that, we can just use this every single time, and we don't really need to care which of these is bigger. Now, the other thing that we need to know, and this is new for us, this year we are going to be finding the foci. This is the equation for the foci. C squared equals A squared minus B squared. And that tells us the distance that the foci are from the center. And A squared minus B squared, we just need to remember it's the big denominator minus the small denominator. Lastly, if the center's up at 0, 0, okay, the origin, this is what our equations will look like, because we know it would be like x minus 0 squared, so just x squared, and same thing with the y. So, here's some example of some ellipses. This is an example of one that has a major axis that is horizontal. We can see that this distance 2a is bigger than the distance 2b. This one has a major axis which is vertical, so this time going up and down is bigger than going right and left. The only characteristic we really haven't talked about yet is something that we call the eccentricity of an ellipse. Okay, the eccentricity is measuring the ovalness of an ellipse. So it's telling us, is it closer to being circular, or is it closer to being more like horizontal and more elongated? Okay, and by horizontal, it could be horizontal or vertical. It could go either way, okay, but it's just not as circular. So the way that we find that is we do E is equal to C over A. So this is something that we also need to have memorized. So you guys are kind of seeing we have a lot of stuff that needs to be memorized this particular chapter. A is the square root of the bigger denominator. Okay, so if we're talking about this, it says we use the eccentricity to measure the ovalness. When C over A is closer to 0, the ellipse is more circular. When C over A is closer to 1, the ellipse is more elongated. For every ellipse, the eccentricity will be between 0 and 1. Okay, for example, the eccentricity of the moon has, the orbit of the moon has an eccentricity of E equals 0.0549. So is that more circular or more elongated? And we would say this is more circular because that is definitely closer to 0 than it is to 1. So let's go ahead and do example 1 where it's asking us to kind of do everything. So we need to figure out the center, the vertices, the foci, the eccentricity, the major axis length, and the minor axis length. So it says 4x squared plus y squared equals 36. So I'm going to go ahead and kind of zoom in here and write 4x squared plus y squared equals 36. First of all, I can tell that this is an ellipse because both x and y are squared, they're added together, and they have different coefficients. I can also tell that this is not one where we need to complete the square because I do not have an extra x or y in the equation. So my goal then is to go ahead and get this into the correct form, which means I need to somehow make that 36 equal to a 1. So the way that I'm going to do that is to divide everything by 36. Okay, so this would become x squared over 9 plus y squared over 36 equals 1. So some things that we can figure out right away. Our center here, since it's x squared and y squared, is going to be 0, 0. Okay, next thing it asks us to find are our vertices. Okay, to find our vertices, that is going to be how far are we moving in the major axis. Okay, so if we compare these two denominators, I notice 36 is bigger, so y is going to be the major axis. Okay, so what this is going to tell me, I'm going to square root that number, and that's telling me that I'm going to move 6 in the x direction. Okay, the x denominator, not in the x direction, I don't know why I put that. In the y direction, there we go. Okay, the x denominator is 9, so when I square root that, that tells me I'm going to move 3 in the x direction. So I'm actually going to go ahead and sketch this first. We've kind of talked this whole chapter about how often it's easier to sketch things and then talk about the characteristics. You definitely can do it the other way as well, but I just think that this can be helpful. So I'm starting at 0, 0. I'm going out 3 and 3, and then up 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. If you guys remember, an ellipse is oval shaped, so I'm going to go ahead and connect those points. That was actually pretty perfect. And if we look, these points right here are going to be the vertices. The reason why those are the vertices is because I am moving in the major axis. So if we look, it looks like I'm moving up. I'm going 0 and then up 6, and then 0 down 6. So I'm going to say my vertices are 0, 6, and 0, negative 6. So it's important for me to know that the vertices are always on the major axis. Okay, next thing I want to find, what is the major axis length? Okay, so I'm going to scroll back over here to this picture, and looking at it, it looks like I'm moving 6 up and 6 down. So that would give us a major axis length of 12. Okay, now how could I have done that without using the graph? I'm taking my bigger denominator, I'm taking the square root of it, which is 6, and then multiplying it by 2, which is 12. Okay, our minor axis, so that's the smaller one, so I would do the same thing. I'm taking my smaller denominator, which is 9, I'm square rooting it, which is 3, and when I double 3, I get 6. Now, if I look back here on this, it looks like I'm going 3, 3, so I am moving 6. So just to review, this is my major axis, and this is my minor axis. Okay, so none of that stuff is too bad. Okay, now we're really going to get into the new stuff. So I need to find the foci. Just so you guys know, the foci are also going to be on the major axis. So the vertices and the foci will always be on the major axis every single time. So in order to find the foci, I need to do c squared equals a squared minus b squared. And remember, we said this just means I'm doing big minus small. Every single time, big minus small. So I get c squared equals 27. So c is the square root of 27, which is 5.20. Okay, so back here, I'm going to have to move up 5.20 and down 5.20. So our foci appear to be at 0, 5.20, and 0, negative 5.20. And one thing that I want to stress here, notice when y is the major axis, only the y value of the vertices, center, and foci are changing. The x values are all identical. The final thing that we need to find is the eccentricity. Just to remind you, it is c over a. We just found that c is radical 27. A, we said, has to be the square root of the big number, which is 6. So I get 0.866. Okay, so a lot of info for one problem, but the way that we find these is going to be consistent every single time. Okay, so looking at number 2, it looks like we're doing pretty much the same things, but what kind of stands out to me here is that we have these extra terms, so that means that we are going to have to deal with CTS. So I just want to remind us that when we are using completing the square, we do need to begin by factoring out the leading coefficient. Okay, so I'm going to zoom in here, give myself a little space to work. So I'm going to start by grouping together my x terms and grouping together my y terms and moving that 9 to the other side. So let's begin with this first group. Okay, my x squared coefficient is 1, so I'm good there. In order to determine what to add, I'm going to take 6, because that's that middle term, divide it by 2 and square it. So 3 squared is 9. So I'm also going to add 9 to the other side. Okay, now, with this second one here, I notice we have a 4. So before I do anything, I need to factor out that 4, and I'm left with y squared minus 2y. Okay, otherwise, I would not be able to make this into a perfect square trinomial. So now I'm going to take this middle coefficient, which is negative 2. I'm going to divide it by 2 and square it. So I'm adding 1. Now, when I balance this equation, the thing I need to remember is this is like 4 times 1, so I need to add 4 to the other side. So now when I factor this, I get x plus 3 squared plus 4 times y minus 1 squared equals 4. Now I need to get that 4 equal to a 1, so I'm dividing each term by 4. And I get x plus 3 squared over 4 plus y minus 1 squared over 1 equals 1. So now we can determine these characteristics. So I'm going to start with our center. Okay, our center this time is negative 3, 1. Because I'm taking the opposite of these numbers. Now off to the side, I'm just going to write, okay, in the x direction, I'm going to move the square root of 4, so I'm going to move plus or minus 2. In the y direction, I'm going to move the square root of 1, which would be plus or minus 1. I can see that 4 is the bigger denominator, so that means that x is going to be my major axis. So on my graph over here, okay, here's negative 3, 1. We said in the x direction I'm going to move 2, and in the y direction I'm moving 1. Okay, so there's my sketch. Now I can see from this, and let me label, these are my vertices because that is the major axis. So it looks like my vertices are going to be at negative 1, 1 and negative 5, 1. So I'm going to go ahead and write vertices, negative 1, 1 and negative 5, 1. Okay, the foci, okay, we said the way we find the foci is c squared equals a squared minus b squared. So c squared equals big minus small. So c squared is 3, which means c equals radical 3, which is approximately 1.73. Okay, technically, if they just asked us for the foci, I would also be fine if you guys like moved radical 3 and wrote it like that. That's totally fine with me. Okay, or we could also just be like, okay, I'm going to move 1.73 to the right, so like 1.73. So this value technically should be like negative 3 plus 1.73. I'm also going to move 1.73 to the left, which would be negative 3 minus 1.73. Okay, so I want to point out here that our foci are always inside the ellipse. If for some reason you got foci that were outside the ellipse, we know that we made a mistake, okay? So if I go ahead and compute those values in my calculator, I get negative 1.271 and negative 4.731. Our eccentricity is equal to c over a. So I have radical 3 over 2, because remember a is going to be the square root of the bigger number. And I get 0.866. Okay, so this is the information that we have. So we're seeing this is really important info for me to have memorized. We're going to practice one more of these. Okay, and we're going to see we are being really consistent every single time doing the same exact steps. Okay, example number 3, which is the final one that asks us to find all the characteristics. Notice this time it doesn't ask us to sketch. I would always advise, if you are a visual person, sketch it out anyways because it's really helpful in finding the characteristics. So, here we go. I can tell this is an ellipse because I have x squared and y squared added, different coefficients. I know I need to complete the square because of these extra terms. So I'm grouping x terms together, and I'm grouping my y terms together. And I'm moving my 8 to the other side. Now, In that first parenthesis, I notice that I have a leading coefficient of 4, so I'm going to factor that out. When I take negative 2, divide it by 2, and square it, I'm adding 1 inside. For my second parenthesis, I'm good. I just have a y squared, so I'm going to take 4, divide it by 2, and square it, which is 4. Now, I need to make sure that I balance my equation. So this would be 4 times 1, which is 4. My second one, I'm just adding 4 because we don't have another number out here. Now, technically, this is a 1, so you could think of it as 1 times 4. So when I factor this, I get 4 times x minus 1 squared plus y plus 2 squared equals 16. So I need to divide everything by 16, and I get x minus 1 squared over 4 plus y plus 2 squared over 16 equals 1. So right away, I can see that y is the major axis because this 16 is the bigger denominator. So our center, we should be really good at finding the center. It would be 1, negative 2. The next thing it's asking me for are the vertices. Now, this is something where I know that I'm moving in the y direction. I could technically do this by hand. Okay, and let's talk about it. This 16 means I'm moving 4 in the y direction, which would be up and down. So technically, that means I'm going to add 4 to the y value and subtract 4 from the y value. So I would get 1, 2, and 1, negative 6. Now, let's say that is not the way you think. Okay, that's fine. Here's just a little sketch here. There's 1, negative 2. I need to move. This 4 is telling me to move out 2. Let me actually just draw some things there. Okay, 2 in the x direction. And then 1, 2, 3, 4 in the y direction. 1, 2, 3, 4. So if you want to do a quick sketch like that, that's great. And then we can actually see what the vertices are. And it looks like they are at 1, 2, and 1, negative 6, which is exactly what we wrote. Okay, so whatever is easiest for you guys, please go ahead and do that. Next thing that they're asking us to find are the foci. Okay, the foci, we know are moving in that same y direction because that's the major axis. I'm going to do c squared equals a squared minus b squared. So c squared equals big minus small. C squared is 12. So c is radical 12, which is approximately 3.46. So if I'm looking on my graph, that means I'm moving up 1, 2, 3.46 and down 1, 2, 3.46. And when I add 3.46 to negative 2, I get 1.46. When I add when I subtract 3.46 from negative 2, I get negative 5.46. Lastly, my eccentricity is c, which was radical 12. And the reason why I'm using radical 12 there instead of 3.46 is because we just want to be as exact as possible. And the square root of the bigger denominator, so the square root of 16, which is 4. So I end up getting 0.866. So these are our characteristics. So about half of your homework is going to be like that. The second half is going to be finding the equation of ellipse. So now they're giving us info and we have to write the equation. So we're going to do 2 examples of this. So number 4 says find the equation of the ellipse having vertices at 0, plus or minus 8, and foci at 0, plus or minus 4. Okay, so our motto this chapter, when in doubt, draw it out. So I'm going to go ahead and sketch this. So notice they don't tell me a center or anything. They just tell me, okay, here at 0, 8 is a vertex, and here at 0, negative 8 is a vertex. And I have a focus like here at 0, 4, and a focus like here at 0, negative 4. Okay, I don't really know what this looks like, and that's okay. We know it's going to be something like this, but things we do know. Okay, first of all, this is going to be the major axis. So in this case, it is y. And the reason why y is the major axis is because both the foci and the vertices are on that value. So that means that y should have the bigger denominator for us. Okay, secondly, I can figure out what the center is because we know we move the same distance away from the center to get to both the foci and the vertices. So I can see that the center here is at 0, 0. So what that tells me is that it's just going to be x squared over something plus y squared over something equals 1. Okay, x squared and y squared come from the fact that the center is 0, 0. Now, in order to find those denominators, we actually already can figure out one of them. Okay, we can see that we're moving up 8 and down 8. Okay, so I'm just thinking if we're moving up 8, we need to square that value. So I'm going to get 64 as my y denominator. Okay, if we look at previous problems, and I'm actually going to move up here to this one. Okay, to figure out how far we were moving, we took these denominators, we took this 16 and we square rooted it, and it told us how far to move. So we're doing the opposite thing here. I'm seeing how far we moved in one direction, and I'm squaring that value to get that denominator. Now, we have to use the foci for something, so I'm thinking we're going to use that for c squared equals a squared minus b squared. We can see the foci are 4 away from the center, so I'm going to say 4 squared equals a squared is our big denominator, which we know has to be 64 because that is the major axis, minus b squared. So I get 16 equals 64 minus b squared. Negative 48 equals negative b squared, so 48 is b squared. I don't care what b is, we just want to know what b squared is so that we can write our equation. Okay, so once again, what we did here, we knew c is the distance from the center to one focus. Since this is 4 away, I did 4 squared equals big, which we already knew, minus small, that's what we're trying to find, and we use that equation to find the smaller denominator. Okay, last example of the day. We're finding another equation. This time they tell us the foci and they tell us the major axis length. Okay, so I'm going to go ahead and sketch this out, and I'm going to be a little bit more specific this time, okay, like with some really accurate little slashes. Okay, so the foci are at 0, 1, okay, I don't know why I made slashes that way. Okay, so 0, 1 is here. And then 4, I would go 1, 2, 3, 4, 1. That's why I made slashes both ways. Okay. And it tells us that the major axis length is 6. Now, what I know right away, since I moved in the x direction for the foci, the major axis in this case has to be x. What I'm going to do first, though, I'm going to figure out what is the midpoint. So there's a few ways we can do this. We can actually just do it by looking at it. We can use the midpoint formula, which is really finding the average of the 2 points. Either way, I notice that our actual center here should be at 2, 1. So that tells me x minus 2 squared and y minus 1 squared. So now all we need to find are the denominators. Now a major axis length of 6 tells me I'm moving out 1, 2, 3, 1, 2, 3. Okay, so I'm moving out 3 in each direction. Okay, this is just a quick sketch of what this could possibly look like. Remember, the sketch is just to help me out. Okay, if I move 3 in one direction, 3 squared gives us 9. So 9 is going to be the x denominator. The reason why it's the x denominator is because I'm moving in the x direction. Now, last thing we need to find is going to be our other denominator, which corresponds with y. So I'm doing c squared equals a squared minus b squared. This time I can see that the foci are 2 away, right here, 2 away from the center. So I'm going to do 2 squared equals big, which is 9, minus small. So 4 equals 9 minus b squared. Negative 5 is negative b squared, so 5 is b squared. So our denominator becomes 5. So my big caution to you guys is definitely to spend some time studying this information. Okay, the reason why students tend to struggle on this particular chapter is because I really think that they do not spend enough time memorizing all of the given information. Okay, there's a lot of information we need to have memorized. I think it is best if we kind of take it one section at a time, make sure you know all that stuff before we build on to our next lesson. So just so you guys know, we only have one more conic section to go. Next time you hear me, we'll be talking about hyperbolas.